is 3 months older,
Mhm.
no, 6 months older than Cole. But she's Riley Nicole, so she's named after me, but they share the Cole Nicole thing.
Uh-huh.
And then I was pregnant with Drew when her son Kyle was born, and her husband called me to say the baby was born. And he said, it's Kyle, but we can't decide if it's Kyle Alexander or Kyle Andrew. And I said, well, I'm picking Andrew. And he was like, then it's Kyle Andrew. So both sets of our kids have like linked names. It's really cool. I like that.
Yeah, with the same, like,
I'll
especially
see
with our
those
close,
things. So that's really cool.
yeah.
What does your name mean?
Myself, Azisha.
Mhm.
Azisha, like it's like a little different, but it means like something knowledgeable or something.
Nice.
meaning.
I like it.
But other of my kids.
Knowledgeable.
Ah,
What's your ethnic heritage, if you don't mind my asking?
like ethnic, like Asian, we're Asians.
Yeah, but I mean, like, are you more, is it India, Pakistan, like India,
India.
north or south?
South.
Mhm. Your dad's kind of
No,
north.
actually not exactly. He's in the middle of the
Uh-huh.
India, but they are settled in South.
So
That's the
one of Jason's best friends from college, her family, she's Bengali.
Oh,
Indian.
because that's North.
Yep. And so she was one of my bridesmaids, and her name's Rimjim,
Uh-huh.
but she always goes by Remy.
Uh-huh.
And she cracked me up when she had her kids. She was in San Francisco, and her husband Shayantam, but he goes by Sal. Dasgupta is their last name, which is like Smith, right? I mean, Dasgupta is everywhere. That one in Patel. So anyway, she had her first daughter, and she named her Malika, but she calls her Lily because she wanted her to have like a very Anglo nickname.
Uh-huh.
And then her second daughter's name is Natalia. And she calls her Ella, and I'm like, Natalia. And she's like, well, she was born near Christmas, because that's natal Natalia. And I was like, yeah, but y'all are Hindu. And she's like, not really. Give up on you.
Yeah, something like I just
Yeah, I need to ask my brother-in-law sometime, because his entire family, almost all of the men have the same extension. He's Nasrullah, and he has a Ramatullah and a Namatullah and a something else too, but they're all, and I don't know what that is. I don't know what that extension on the back of their name means. Yeah, I don't have a clue. It's interesting though, like that I didn't realize that was all their names, but so he's from Kabul, my brother-in-law. And hi, Mitchell. And so when everything went crazy over there last October
where?
in Kabul,
Okay.
Kabul, Afghanistan. So when everything went down, it was god awful, right? So we spent probably a month and a half trying to get his family out. We couldn't get him out. But that's how I got all their names, because I had like all their names, I had passport photos, like in case I got somebody that I could just hand them to really quick. Because my brother-in-law was my sister's translator, because she was in the Air Force over there. So that's how they met. And that's when I got married. So his brother was also a translator. And no, his uncle, not his brother, his uncle. And then his dad worked for the education department. And then all the bad guys came in. He was trying to get his family out, but the only one that the US government gave like a pass to was his brother, because his brother was actively employed as a translator. It didn't matter that the rest of the family, was completely involved and totally vulnerable, and didn't matter that, the people in the village certainly know my brother-in-law and know he married an American lady. So it was really bad. And we tried, we could not get them out. They're still there. It's awful.
Still your sister also?
My sister's here in the US with my brother-in-law. He's a citizen now, but we could not get them out no matter what. My sister had like special ops people, because we knew it got to a point where we knew the regular pathway was not going to work. So we started looking for like special ops guys that could go in and extract them. And we got really close one day, because she ended up calling them and telling them, I need to know what you're wearing, so they could tell the special ops people what they were looking for. And they were told, keep your head on a swivel. And then something happened and they had to pull out, and so they're still there. And they're all in a house, and they can't leave the house, because the men can leave, but the women can't leave. They're stuck in the house.
I understand.
Yeah.
It's very hard for the people over there.
It's terrible. Well, and like they very quickly slapped down a burqa law, knowing that there aren't enough burqas in all of Afghanistan to cover all the women in Afghanistan. So they are shut in the house, and that's what they wanted. So there they are. And it's awful. Like his sister last year should have been like her senior year of high school. And all of her family has at least a college degree, if not a master's degree, and she can't even finish school. I was so mad. Like she's like one of these kids, you know? So I was like, how can I get her curriculum somehow? Can I mail it? Can I do it online? Not enough bandwidth to do it online. They
That's
intercept
actually,
all
you
the
know,
packages.
So
Can't,
stopping the education, I think so, is one of the biggest crime. That's what I, because education is most important for every, they have
Yeah.
right to rights, right?
and everything was intentional. I mean, that was the biggest part of the burqa law, I think, was just it absolutely kept women in their houses. And then it was like, if your woman is outside the house without a burqa, it's the man that gets punished. So
The man won't leave it.
yeah, the man gonna do, yeah. I mean, they'll punish him for letting her out. Shame on you, you let her out like she's a dog or something. Yeah. It's just awful. So we pray all the time because that's all we can do. Because we've tried everything else.
I'm so sorry. For
No, you're fun. I like chatting, getting to know parents. It's fun. Getting to know parents is cool. If you put it in the green folder.
Take it out.
Yep. Take it out and put it in the green folder on the chest over there.
Shall I keep his, like, the he didn't have proper breakfast? Shall I just-
He can eat now or whatever he wants.
I just keep some.
Yeah, just let him. He's fine. Here you go. All right, Yusuf, you're good, man. Mitchell, what, did you dress up last night?
Yeah.
Yeah, that took you a while. Are you sure? See, as he's yeah, what'd you dress up as? What'd you do?
80s kid.
An 80s kid. Oh, you were all prepped from Tinker Day. You had a lot of that going on.
And from the decade, I just wore the same costume for the last month.
Like on.
I was gonna ask you, did you dress up or did you not go out? What'd you do?
I had like work to do at home.
Oh, do you usually go out or do you usually stay home?
I usually go out.
Do you? What was your plan? Did you have a plan?
I was planning to go like Blue Ridge Mountain to Black Mountain.
A mountain? How are you gonna dress as a mountain? I'm curious now.
Huh?
How are you gonna dress as a mountain?
Friend dressed as a rooster.
Oh, that's good. All right.
Could barely like we had a steep hill.
Yeah.
Could barely go down. His house was like at the bottom. He could barely climb up.
Oh my gracious. Wow.
Yeah, my neighborhood does not do trick or treating if you're over the age of 10. Yeah,
They would rather the teenagers be out causing trouble than collecting candy. What neighborhood is that?
I
No,
mean,
you live very far out.
17 years old and he's
I'm
still
only 10 minutes from
That's a little old.
I'm gonna be the.
Are you? I thought you were further out. No, it's Liam that's further out. One of you guys, new guys.
I'm only
is further out.
the beef and
I
the neighborhood. The one on the right, they're nicer, but like, there's not as many people there.
Well, you should come here one Halloween because here's what I learned the year we moved in. Nobody comes to my house to trick or treat. And I was very let down by this, but then I realized what happens. So the main street is kind of at the top of a hill, right? Everything that goes, all these cul-de-sacs that go down, they all go down towards the river, right? The land slopes. So they don't want to walk down. So everybody walks the main street and a lot of people in this neighborhood
Oh,
have
yeah.
golf carts.
I'm on a hill too.
Yeah. So a lot of these people have golf carts around here because it's a golf course and they have their little golf carts and they do the golf carts like a trunk or treat. Like they decorate them up and they drive up to the tops of the hills and they wait for kids to come by and it's all on that main road. So it's real easy because they're all right there. It's just house to house to house. So nobody came here. I put out candy last night and I came home and it was all still there. So I was like, oh well.
How fast does your golf cart go?
I do not own a golf cart and I do not plan to own one. Although there was a guy last night dressed like Michael Myers and he was flying around the neighborhood in a golf cart and it was pretty funny. So
No, we have a golf cart that we use in Florida. Because in Florida, there's a golf cart law.
oh yeah,
You can have a golf cart to drive if it's like 25 miles an hour.
yeah.
So ours was like 25, 26 miles.
And Peachtree City has that kind of rule too. Yeah. What were you gonna say real quick? And then we'll start.
My cul-de-sac is like very bad for trick or treating because many people came with inflated sharks or snakes and there are like so much nails in the floor it's all pop.
That's not great. All right, well, let's start. Welcome to Q2, by the way. We have made it through the first quarter. So now grading for you guys is going to start fresh and new this quarter. Okay, brand new for you and all over for you. So if you get to a lesson and you're confused by anything, the content of the lesson, the reading, if the reading doesn't line up with the binder, like we had an issue with that Mitchell caught, and it was super frustrating because he didn't know it was that he was doing wrong and he wasn't doing anything wrong. I had put the wrong thing in the syllabus. I put the wrong chapter. So I messed that up and it messed him up. So you guys are the first junior lab rats I've done earth science with. This is my fourth loop around, my fifth year, my second earth science, but my first junior. I only had one class last time. So if there's going to be mistakes, it's going to pop up with you guys because I haven't done it yet. So let me know. Okay. If you see anything, never, ever, ever get frustrated. If you get frustrated, quit doing your work and text me and say, hey, I'm stuck. Right. Just texting me is the fastest way because I'll see my text immediately. May not answer, but I'll see it. Whereas emails, I might not see till like 11 at night or whenever I get to them.
Texting, like, what do I text? Like, on like the Facebook or whatever, like.
You text the phone, my phone number's in the syllabus. You just text it and you say, hey, Miss Daniels, this is Yusuf. I don't understand, whatever. And I will get to you as soon as I can get to you. Okay, so we are starting our second quarter. So grading starts here. And you both have your syllabus with you, right?
Yeah.
Let's just do this for the heck of remembering what's going on, since you guys are both new here. Mitchell, if you will turn to page 3 in your preface, this is how you are graded. So you will have, for extra credit options, you can complete any up to 3 questions, or actually up to 5, I think it is well, we'll give you credit for 3 questions at the end of your textbook review section for any lesson. So if you're reading chapter 14, there's a 14 review in your book. If you want to do this, okay, all right, well, maybe, I don't know, maybe it's not there, I'll look for it, whatever. So anyway, you can always add those onto your test, and there's directions there for exactly how to turn it in, okay? And you can email it or you can put it in paper. Late assignments, okay. This is for things like your project and your final exam and your
This is
midterm.
not absent on Tuesday because we don't do anything on Tuesday.
That's perfect. So your final project, your midterm and your exam, those won't be accepted late. So be sure you get it done. Your class participation, so your full credit is earned if it's completed in 8 days. So that means if you're absent for a day, what do? How do you get class participation? Do you know? You go watch the YouTube video of your class, the one that's recorded right now. And then you comment and say, I watched this, and that's how you get class participation credit if you're absent, okay? Or you can tune into the live stream, and then I know you're there, same thing. All right, so that's how you get class participation credit. So after 8 days, I don't give it to you, it's done. You don't get dinged if you do it 3 or 4 days late, but if you wait till 8 days, you don't get any at all. Now, your stuff like your homework, binder work, lab completion, unit tests, if they're a day late, it's 5 points off. If they're a week late, it's 10 points off. If they're 8 days late, no points, period, no credit, you're done. So if there's a valid excuse or something crazy happened, or you're super sick, or you know, your pet chipmunk got run over by a tractor trailer, you know, you let me know, and I will then there for you. I'll do whatever you need to do. And then be sure when you're handing in anything digitally, you follow that format down there and you do PDF. Yes, sir. Always with the PDF. All right. So here is lesson
My
11.
computer, it always, like, default option is PDF.
There you go. Yeah. And so I even put instructions in the in there on how to use like Tiny Scanner. That's the app I use on my phone. It's a great app. It makes PDFs like this, really easy. All right, so here we go. We're talking about atmosphere today. So we're getting into weather. So weather versus climate. So what's the difference here? So weather is your short-term state of the atmosphere. It changes all the time, daily, hourly, sometimes weekly, and it's affected by things like the season overall, but then there are smaller factors like where are air masses, what's the barometric pressure, what's the humidity, things like that. Climate is your long-term weather pattern. I think it's typically like a 30-year average. So they take like an average of everything, and that's how they come up with climate. And there are different climates, right? There's subtropical, there's tropical, there's all different ecosystems too. So there's like tundra and taiga and savanna and all that. And all those things share characteristics with one another. Like one savanna is like another savanna. And that's due a lot of the time to their latitude. Yep, it's their average weather patterns over, like, I think it's 30 years is what they use. But anyway, it's an average. And so there's obviously going to be changes. And it's helpful to know the climate where you live, where you don't want to live, you know, once you may not want to live in a tundra. I don't think I would want to live in a tundra. Yeah, I don't think I would want to live in a desert either, but I've been to like Arizona and it's not too bad. Remember that desert doesn't mean hot necessarily. It's dry that makes something a desert. Okay, so moving on. Atmosphere. So what's the atmosphere? This is this thin layer of air that surrounds the earth. It's made of gases such as oxygen, nitrogen, carbon dioxide, and then things like dust, water vapor. And it's held to earth by gravity. So gravity is what's, got to put this up here. Gravity is what is keeping all of that air close to earth. Kind of weird to think about gravity acting on air, but it is. Gravity is acting on air. And it's important because it protects us from the sun. So we cannot do UV rays. They're not good for us. They're really not good for people that look like me. The UV rays are not my friend. So without the atmosphere to protect us, we would all just fry. Plus, it also adds the opportunity for things like the greenhouse effect. And that is what makes it possible to live here and we're not freezing it sometimes. Yes.
But no, but the UV rays only stop at the stratosphere, right?
A lot of them do, and they'll bounce back off. But some come through. Some stop there, but there are always some that come through.
Holes in the
Very good. Yeah, till you've done your reading. So atmospheric composition. So look at this dude. Who's he look like? You look like anybody you've seen before?
No.
He's an ancient Greek guy. He's just a generic computer graphic ancient Greek guy, but he looks a little like Santa after he got out of a sauna to me or something.
babies or what?
Yeah, no, I don't know. So the ancient Greeks believed that air was an element and couldn't be broken down.
Fire.
Air, fire, earth, water, these are their elements, right? They didn't understand elements the way we understand elements. We understand elements on a atomic level, right? And does anybody know who was responsible for organizing our modern periodic table? You know, the scientist that was the
Dimitri or something?
Yes, Dmitry Mendeleev. Way to go, Yusuf. That's a really good one. Dmitry Mendeleev is the dude who organized our current version of the periodic table. And he's a Russian dude, and all of the pictures of him, he looks like some kind of psycho murderer. I don't know why.
But spaces in the
Because he knew things were there that we hadn't found yet, but he knew they had to exist. Bless you. So we now know that air is made a combination of many gases, and these gases form our atmosphere. Now, some of those gases are in elemental form and some are in compounds. For example, oxygen by itself, it doesn't like to be alone. So it's always with another oxygen. So it's like O2, two O's together. But then when you have carbon dioxide, it's CO2. So you have a carbon that joins them, right? And then water, you got H2O. So you have two hydrogens, one oxygen, right? So some of the things in our atmosphere are going to be just pure elemental form, even though O2, there's two oxygens, it's still just the element. Others are going to be compounds. So atmospheric composition, let's give this a shot, guys. So the percentages of nitrogen and oxygen are important for life. What's our percentage of nitrogen in the air? Oh, the both of you are good at this. All right, so 78. Yeah, you got I give you both. Yes, it's 21. There you go. Y'all are good. So everything else, whoop, hello. And everything else is going to be your 1%. And that's stuff like argon, hydrogen, carbon dioxide, water vapor, and other gases. All those things, helium. Yep. So if you look at that, think about how much hydrogen we need on this earth to make water. Some of it's in water, some of it's in other things chemically. Look at carbon dioxide though. But what's the greatest source of carbon dioxide production on Earth? Do you know? Nope, those both produce it. Yes, but the thing that produces, well, actually, no, I think you're right. What I meant to say was oxygen. My brain said. I meant to ask you, what is the? You're right. Yeah, specifically, do we know what? So everybody thinks that. And like a couple years, the rainforest was on fire a couple years ago, and people were posting memes of the rainforest and pictures of it and saying, oh my gosh, Earth's lungs are on fire. And it's like, kind of, but not quite. I mean, it's a tragedy, but really what's responsible for most of the oxygen in our atmosphere that we breathe are phytoplankton, cyanobacteria, that phytoplankton that live in the ocean. Yeah, they produce more oxygen than all the trees. Kind of crazy thought. And so where you see your little Rico there, that's for you to remember, right? The most abundant element, most abundant gas in the atmosphere is what? Nitrogen, then oxygen, then everything else, right? You have to have oxygen or you couldn't light a fire. Think about that.
Why do we need nitrogen?
You know what? It's part of, there's a nitrogen cycle. That's important. Although we don't, they use it, and yeah, it's just part of the way biological organisms recycle chemical compounds, but it's it's important for things like that, but although we don't breathe it, it is part of other compounds, so that's important. So key atmospheric gases. So what do you call water in a gaseous form, especially when it's below boiling temperature?
Water.
Water vapor is right. Okay, so remember that if you can see it, it's water vapor. If you steam, steam is pretty much invisible to your eye. So remember that. If you see it, you're seeing the water vapor, but it's probably around some steam. And that's because it started to condense because it's just cool enough to do that. And so, like the amount of water vapor at any given time or place changes constantly, right? So the percentage changes with seasons and the altitude of a mass of air, whether it's high or low. And then carbon dioxide and water vapor regulate the amount the atmosphere absorbs. And then water is the only substance in the atmosphere that exists in 3 states: solid, liquid, and gas. You can find water in the atmosphere in all 3 states, which is true of only water, nothing else. And when it changes state, it's going to either absorb heat or release heat, depending on whether it's freezing or it's melting, or it's turning into vapor, or sublimating. We get to snow, we'll talk about sublimating. So your key atmospheric gases. So what's this? No, sorry, we're back on solids in the atmosphere. So do you know what is carried into the atmosphere by wind? It's a solid. This is good. Yeah, you're close. Dust. Yeah, very good. All right. And then what is picked up and carried into the atmosphere from ocean spray? This is like when waves go and the water comes poofing up. So that's salt. There's actually salt in the atmosphere, and it's picked up in the atmosphere due to the ocean because it's right there, right? It splashes around and it sort of atomizes, and poof, there it goes. And then what is found in the form of hail and snow as a solid? Water, right. Okay, there we go. So when we talk about hail and snow and how hailstones form in a couple of weeks, it's kind of a fun process. So let's see if I can get this up here. All right. Ozone is a gas formed by the addition of a third what?
Oh, oxygen.
A third oxygen. So ozone, we said oxygen floats around in the atmosphere as O2, right? So what's ozone is O3. You are right. So it exists in small quantities, and it's mainly in a layer well above surface. It's going to absorb UV radiation, which is why it's important, and it's thinning. In the 80s, there was a lot of concern when we noticed that in the 1980s, late 80s, early 90s, is when the thinning was really starting to be noticeable, and there were actually little holes, like you could see little holes in it when they did their diagnostics. And they knew that one thing that could cause that was chlorofluorocarbons, which are like, they were in things like hairsprays, different propelled things in cans, and so they were like, oh no, we can't have these anymore, let's all stop. They put bans on stuff like really good hairspray that everybody used in the 80s for the big hair and all that kind of business. And come to find, and inhalers, asthma inhalers, they changed the propellant in asthma inhalers, and my husband swears they don't work as well. And not every government did that. Like the US government did it, but for example, I think Canada did not do that with inhalers. So there are a lot of asthmatics who will order their inhalers from Canada because they like them better. But they found out that methane actually causes holes too. And do you know what's a huge source of methane here? Do you know? Cow farts. Cow farts. And as long as, seriously, cow farts.
Cow farts?
Yep. And as long as we keep farming beef and having tons of cows, we're gonna have cow farts.
What? Oh,
Yep.
That means we can make petrol from cow farts?
Yep. My husband once fussed that all of the asthmatics in the world puffing away don't equal one cow fart. So anyway, pressure is it's physical what exerted over an object. What do I want here? Does anybody know what word I want here?
Air pressure.
I'll give it to you.
I went right over
It is force. Okay. You can think of pressure as a force applied over an area. When we get to physical science next year, we'll really talk about it, but it's a force applied over an area. And it's a measure of force applied over a unit area. You can think of it that way. That's okay. So keep that one in your brain, force applied over an area. So I got to pick up the pace a little here.
See a Rico over there?
Yeah, there was a Rico. Remember that it's force applied to an area. So the weight of the air, I got to keep watching our time. So the weight of the air pressing down on a surface is the air pressure. And the higher you are, the lower the pressure is. The lower you are, the higher the pressure is. So I'm gonna skip over how does a barometer work.
But
I'll put it in your notes. I'm just watching time. If we have time, we'll go back. So air pressure and density. Okay, so this is important to understand. So you see these guys here, these guys on the side, they're standing on each other's shoulders. This reminds me of the Dr. Seuss Yertle the Turtle. If you've ever seen read Yertle the Turtle, it's a great one. So there are more molecules of air pressing down on someone at the very bottom, closest to sea level, closest to Earth, than there are somebody up high. So he has less pressure up high because there are less molecules. You think of it like a column of molecules. The guy at the bottom has more than the guy at the top, right? Why is that? Why are there more molecules at the bottom than at the top?
Gravity.
Gravity is it, my friend. Yes, gravity is pulling the air down, just like we said, pulling the atmosphere down. So you're used to the pressure of the air that you live in. The atmospheric pressure you live in. Fish are adapted to be under the ocean where there's a lot more pressure, right?
How can we like the one that want to challenge you deep? Like how do we?
Mhm. So what do you think I want here? Pressure what? With depth in the ocean. Pressure
Water.
increases with depth. So I don't know why that other box is there. Pressure increases, because it goes here. And then pressure, okay, so pressure increases with depth of the ocean, and it does what with height on land?
It decreases.
Decreases, right? Increases the deeper you get in the ocean, decreases the higher up you get. Okay, so density. So you can think of density, it says proportional to the number of particles occupying a space. Density is how much mass is in a given volume, okay? Doesn't matter what the mass is, doesn't matter if it's a liquid, a solid, a gas, how much mass is within a given volume. So like a cubic centimeter or cubic meter or whatever. And so as temperature increases, pressure increases and density decreases. And that makes sense, right? As it expands, because it gets hot, things expand, gas expands when they get hot, right? Because the molecules get excited, they start bouncing around and it expands. That's why pressure cookers have those like locks on them, right? Because if not, the lids would just come flying off. And then as temperature decreases, pressure decreases and density decreases. That's true with everything, but water is a little different in that regard.
Like water freezes, the molecules expand.
Yes, when water freezes, it crystallizes and the molecules lock into a different position. And that's why it's necessary, because if water became more dense when it got really cold, it does because it sinks. But when it freezes, it then becomes less dense. That's why ice floats in a glass. But if ice didn't do that, we wouldn't have anywhere for our fish and sea life to go when the water freezes over. And it's necessary for life that water behave the way it does. So, solar fundamentals. All right. Okay, so here's your graphic. It says different areas absorb energy and heat at different rates. This does not heat air directly, and air is heated by conduction and convection. So which one do you think I'm looking for here? If I said it's heated by conduction and convection, what's the one that's left out?
Radiation.
Yeah, radiation. So, let me put these last two up. Okay, so yeah, so radiation. Go on. There you go. So radiation is like the sun's heat coming down. You're not touching the sun. It's not direct heat. It's the heat coming from the sun warming the earth. And then, oh goodness, somebody animated all those. So then the next thing says transfer of energy occurs when molecules collide. And this is like you put a pot on the stove and the heating element heats the lower molecules, which heat the molecules above them. Which one? Conduction, that's right. Just like electricity goes down a wire, heat is conducted the same way. When you touch a surface, that's conduction, okay? And this last one is convection. And this is transfer of heat by flowing of a substance. And convection is going to be really important when we get into tectonic plate activity. It's part of that process, and it's super essential. And we do a really fun lab with Ritz crackers and tomato soup, and it's pretty cool. Yeah, super cool. All right, so this is temperature. That's what goes here. I think y'all saw that. I want to make sure that I get it up here because these are kind of weird. All right, so your temperature versus heat. Your temperature is the measure of how slowly or rapidly molecules are moving. That's what temperature is. It results in heat, something feeling warmer or being warmer. But the temperature itself, what you're actually measuring, is how quickly the molecules are moving. So remember that today in lab, because you're going to be getting some temperatures. So although the result of the change in temperature is either gain or loss of heat, right? But yes, it's actually the heat that the heat you're feeling is a measure of the temperature, if that makes sense. The temperature is a measure of how fast the molecules are moving. So your heat is the transfer of energy. So you're transferring the energy from whatever you're measuring to the thermometer or to your hand. You can touch something and say, oh, this is hot, or this is cool.
How's it
Now,
important?
how is it important?
Like I see people do.
Oh, it's important to remember that temperature is a measure of how fast the molecules are moving, and heat is transfer of energy. That's what I want you to remember. Okay. So for example, if I touch this, or if you guys both touch the glass table, touch the glass table. All right, tell me, how does it feel?
Cold.
Does it feel cold? Okay, now wave your hand around in the air. How does it feel? Colder or warmer? It's the same. Everything in this room should be the same ambient temperature if it's been in here together for a long time and settled in. The reason your hand feels cold when you touch the table and not the air is the conduction. When you put your hand on glass, glass is going to conduct heat better than air. So what you just did is the cold didn't go into you. Things flow from hot to cold, not cold to hot. So when you put your hand there, some of the heat from your hand went into the glass and your body perceives that as feeling cold. That's what happens. So there are lots of ways to measure temperature. We can measure Fahrenheit, Celsius, Kelvin, Rankine, Réaumur. Yeah, we don't do this very often. But you can see why they're important. Like, look at the Réaumur temperature. See how low that goes and see how high it goes. So you can see how they have different measurements. So usually in science, we're going to use Celsius or Kelvin. But here in the US, we use Fahrenheit for pretty much everything. But everybody else in the world uses Celsius. Kelvin's important if you're doing labs that involve things that are very cold. The idea of Kelvin is absolute zero, which means all molecules stop moving, which is a hypothetical.
So the coldest Kelvin is absolute zero.
Right, and it's hypothetical. It's when all particles stop moving. That's the hypothetical.
So basically die.
So I'm gonna keep going quickly. I'm watching our time here. Okay, so when the temperature of the air is cooled at a constant pressure and it reaches saturation, what you get then is this dew point. Okay, so you'll hear that on the weather. The dew point is blah, blah, blah. So the saturation point at which the air holds as much water vapor as it possibly can. So that has to do with both pressure and obviously the temperature, but the pressure is going to matter too. Because remember, when pressure gets higher, temperature gets higher. When pressure gets lower, temperature is cooler. So that's going to matter. Dew point will be affected by pressure, but it's a measure of where the temperature is cool enough that, and it's so saturated that the water is going to start to form little droplets and dew on the grass. Yeah, we had a lot of dew this morning. We have a ton out there.
Dew point.
Yep, he was out there. Filming this morning with the drone. So the other thing we have here is condensation, and you guys know what that is. What's condensation as a state of matter definition? It's when from gas to liquid, right? Okay, so it has to do with when it's cool enough, and this is when you see water falling as rain, or
Wait.
Yeah.
What? So, but carbon dioxide has no condensation, right?
Carbon dioxide.
It goes directly to solid.
It goes, yeah. You don't really see it as a liquid as much as some other, like, not practically, no. Like nitrogen can be made into a liquid, right? But carbon dioxide I mean, practically, no. All right, temperature inversions, just quick, not a big thing for you guys to know. Just know that when you have a temperature increase up high in the atmosphere, you can end up with a warm air lower and cool air rising, which is not typical, right? Typically your warm air rises and your cool air sinks. And this is how you can get pollution issues, because it's going to bring the pollutants up higher. And wind, the reason wind is even a thing is because you've got cool air masses and warm air masses, and your cool air masses are sinking because they're more dense, and your warm air masses are rising, and the shifting of those air masses is what creates wind. And wind will come before a storm, because a storm typically is caused by low pressure in the atmosphere. And as that air mass moves in towards the higher pressure in the warmer, drier air, it's going to have wind, and it'll actually push that that warm front right out. So you get this high and low pressure, and then you get winds.
Wait, how do you measure pressure, like MLP?
For what?
How do you measure pressure?
There's a bunch of different ways to measure pressure. You can do,
Barometer?
yeah, and you hear like PSI is one of the ones we use. That's like pounds per square inch. There's lots of ways to do it. Pascals. It just kind of depends on what you're using it for. So what's number one?
I can't-
What layer of the atmosphere is that one?
Stratosphere.
All right, there we go. What's number two, Mitchell? Do you know?
Troposphere.
There you go. And what is number? Oh, I clicked it already. Sorry. What's what's number four? You give me. Okay.
Atmosphere.
Thermosphere. Yeah. Yeah. We're gonna stick with the basic ones, and then you got exosphere. Okay, so we're gonna go through them super fast because I'm watching our time here, and you guys can look at this and review it later at home. So here is our troposphere, closest to the Earth, contains most of the mass of the atmosphere because obviously it's closest to the Earth. Gravity's pulling on it a lot. Temperature decreases
When you go
from top to bottom, right? The bottom's cooler. Upper limit, they call tropopause, and that is when you get, it varies in height from 16 kilometers at the tropics to 9 kilometers at the pole. So the troposphere is not like a completely consistent depth, height, width, whatever you call that, all the way around, thickness. It depends on where it is. So then we also have the stratosphere. This is where you got your ozone, right? And it absorbs UV rays.
go the warmer it gets.
Yep, and it's pretty warm there. And then your temperature is going to gradually increase towards the top, just like things typically do, right? And your upper limit is the stratopause. There's pause again. We had tropopause, and now we have stratopause. Pause would mean to stop, right? And that's about 50 kilometers above the Earth.
It's a mesosphere, it's where meteor
That's right. So you've got your no concentrated ozone in the mesosphere. Your temperature is going to decrease, and your upper limit they're going to call mesopause, shockingly. And so your thermosphere is going to have a tiny portion of the atmosphere's mass.
Wait, is
Much further.
1,800 Celsius then?
I have no idea that exact number, but you may be right.
It's in the book, it's like 1,800.
I believe you. This says it increases in height to more than 1,000, but I don't know the exact number. Yeah.
Put in a thermometer, it says 0 Celsius because the molecule is not close enough.
Yeah. There you go. Okay. Very smart. There you go. So molecules are so far apart, it would not feel warm to a human. There you go. Even though it is more than the height increases to more than 1,000 Celsius, it's not going to feel warm, like you said.
Like a single molecule is going to be.
That's right. That's right. So lastly, we have our exosphere, outermost layer. It's got your light gases.
Ionosphere.
We're doing the main chunks, not the sub chunks, if you know what I mean. So the exosphere is your outermost layer. You got your light gases. This is where you get helium and your hydrogen. A lot of that's going to be up there because it's less dense than your others. And there's no clear boundary between the exosphere and space. There's no exopause. Fewer and fewer molecules to get to space. Okay, I'm going to save this one. Actually, I think I'll have everybody watch it together in a minute. But it's a great way to remember the layers of the atmosphere. So let's real quick go through relative humidity. So you got humidity, and humidity is the amount of water in the air. Relative humidity is the ratio of water vapor in a volume of air relative to how much water vapor that volume of air is capable of holding. Does that make sense? So if I have a volume of air and it's capable of holding, let's just make it weird. Let's say, 10 whatever, 10 liters, doesn't matter. You got a volume of air that's capable of holding 10 liters of water, and there are 8 liters of water in it. Well, your humidity is 8, but your relative is the 8 to 10, huh?
4 to 5 too.
Yeah, it is. Very good. You reduced it. Super smart there again. So your warm air is capable of holding more moisture than cooler air, obviously, and it's expressed as a percentage. Clouds. Let's go through clouds real quick. You guys probably did you like the clouds unit? I like the clouds part. So clouds form when your warm, moist air rises, expands, cools in a convection current. As the air reaches its dew point, the water vapor in the air condenses around condensation nuclei, they call it. And those are small particles in the atmosphere in which cloud droplets can form. So your cloud formation, you've got clouds can form when wind encounters a mountain. and the air has no place to go but up, and they call that orthographic lifting. So mountains very often will have clouds like on one side like this, and then they have the shadow region where they don't get rain, and it's just kind of weird because the way the air masses move. And then warm air cools, water vapor condenses, you get clouds. So you have stability with the atmosphere as well. So stability, you guys aren't going to do too much with this.
Isn't it like cloud? So the cloud basically evaporation, condensation, and precipitation.
So stability has to do with how stable the air masses are and how quickly they're moving, and that affects cloud formation. But that's more for the other group than for you guys. So then you also have latent heat, and that's what causes air to expand. That can be heat that's left on the surface of the earth. And this is just know that it's there. You guys aren't going to be quizzed on that. Types of clouds. Now, this is where we get fun. Clouds are classified by both altitude and shape. So you can tell what a cloud is based on its altitude and its shape.
How do you measure this altitude? Like when you look up, they're all like.
Well, basically they have low, mid, and high. Yeah. And then this dude is the guy who figured it out. I wanted to get a picture of Luke Howard, but I didn't. I missed it. So your types of clouds. Now, if you look here, they've got low, mid, high, and then they have these little, they look almost like elements, like chemical formulas, but they're not. And this is just ways that like meteorologists can determine clouds. So your height, you've got cirro, those are the highest. And those are over 6,000 meters above. You got alto, those are the ones in the middle. And then you've got strato, and those are the low ones.
So stratosphere.
Stratosphere is lower, right? These are stratosphere means low of, because you think about it, you've got your troposphere, and that's really like what we live in. So the next like layer that's kind of foreign to us would be low, would be stratosphere. That's what we get it. So your stratosphere, these are your low ones. So then you've also got them categorized by their shape. So you've got cirrus, and that means hair. These are these ones that look like, and you can have cirrus clouds and then cirrostratus, and that's because you can see these are kind of flat. And we'll get to that in a second. So cumulus, these are the fluffies. When you see fluffy clouds, the kind that you draw on paper when somebody says draw a cloud, you're drawing cumulus clouds most of the time.
Wait,
They're fluffies.
it's a storm, right?
What now?
Storm?
Yeah, storms are tend to be cumulonimbus. That's this one right here, or nimbus stratus, which we'll get to.
Like divided into subdivisions.
But we gotta watch the time because we're technically out of time. So I'm going real fast through this. So cumulus means a pile or a heap. Okay, so that's why it's like that. These are the puffy ones. Then you got your stratus, and these are your layer. So that means low. So you can have altostratus, cirrostratus, and just straight up stratus. And then they're just kind of like sheets. And nimbus means cloud. So these are the ones that are gray.
What about a cumulonimbus?
Yeah, cumulonimbus are the big ones that, yeah, those are their storms. So your low clouds, you got your stratocumulus, your middle clouds are like your altocumulus, and these are just some little things to help you remember what they are. Your high clouds are the serious ones, and then you've got these vertical development ones, and these are the ones that they're a little harder to understand, so we're not going to have it too much. Now, this is how snowflakes are formed and how raindrops are formed, is coalescence. So with coalescence is basically, that's what results from condensation, right? You have water droplets that come together, and then because of the hydrogen bonds in water, water adheres to itself, and you get these little drops that form. This right here, this Bergeron process, is how a snowflake forms, and it's really interesting. It has to do with the way the water droplets align when they touch the snowflake. And it's pretty fascinating. And I have a great video about that, and I will, I'll link it so you can be sure to watch it later on. You guys know the water cycle. That's easy. We've done it before. And because of that, we're able to have our clouds and things like that. So that should be, oh, air quality, real quick. You guys got a little air quality. So air quality, you know what pollute means? To spoil something, or to basically to contaminate it. So as you said before, your vehicle emissions, your fossil fuels, natural gas, all that kind of stuff, those are your man-made sources of air pollution. Natural sources include things like volcanic eruptions, windblown dust, and sea salt spray, and volatile organic compounds that can come from plants or out of the ground.
Forest fires.
Forest fires, yeah, fire too. That can be natural, or they can be intentional too. But volcanic eruptions can be very dangerous for air quality, very. Now, photochemical smog, this is just your smog that you see. And this is when you've got nitrogen oxides and they come together with stuff and they create this smog in the air that you can actually see.
There's
And
two types of
then-
smog, right? London type smog.
Yeah, there's different smogs. And then your acid rain occurs when the rain falls through the smog and picks up some of the chemicals, or through just the air. You maybe can't see the smog. I visited Beijing several years ago. You can see the smog before you land in the plane. It's just yellow. The whole city is like this brownish yellow, and you can taste the air. If you've ever put a key in your mouth by accident, like, I don't know, ever had keys in your mouth, babies do it. You know what that metal tastes like?
Yeah.
That is what the air in Beijing tastes like. It was gross. So these are just some,
You smell it?
oh yeah, these are some graphics that show you like what percentage of what type of pollution comes from what source. And these are our air quality levels that the EPA puts out. And this is about indoor air quality. So I urge you to go back and look at that, because that's an important one. And we'll skip him because we're out of time, but we will come back to it later. So I'm going to do this video for them. Everybody should do it at one time, so I don't have to embarrass everybody twice. It's great. Hey, y'all, why don't you come on in? Come on in, guys. Class, let's do class. Let's learn. They're taking their time. Here they come. Hello. Hello, hello. Somebody always stops there and then everybody, y'all are funny. All right, so lab today is going to be a fun one and a quick one. So I have a minute to take some time here to show you this video, which is part of both of your lessons, and it'll be in your lessons when you look at them tonight or whatever. If you look over them, this will be there. But it's ridiculously goofy. And it's an earworm, but this man sings the layers of the atmosphere and it really gets stuck in your head. And it's great. I saw it the other night and at first I thought this is ridiculous. And then I started laughing at it about halfway through and I thought this is ridiculously wonderful. So we're going to watch this dude just for the sake of it. So now you will remember the layers of the atmosphere because of this guy.
I already know about the troposphere.
In the troposphere.
There we go. Red and fast.
The atmosphere keeps us safe and warm down here. 5 days here, right here in the atmosphere. Warmer than the air below. Ozone layer parasol. Airplane contrails white like snow in the stratosphere. We love the atmosphere, keeps us safe and warm down here. 5 days here, right here in the atmosphere. Never see a shooting star, the mesosphere is where they are. Coldest layer on Earth by far in the mesosphere. We love the atmosphere, keeps us safe and warm down here. 5 days here, right here in the atmosphere. Molecules extremely hot, radiation ions brought. Space station for astronauts in the thermosphere. We love the atmosphere, keeps us safe and warm down here. 5 days here, right here in the atmosphere. The exosphere is way out there, near space, it's such thin air. Satellites are everywhere in the exosphere. We love the atmosphere.
Catchy, isn't it?
And warm down here. 5 days here, right here in the atmosphere.
What is he?
I like how he looks at himself here. It's like Brady Bunch style. I don't know what he is. I don't know if he's a science teacher or what. I gotta look him up.
How do you find this video?
You know what? I was just searching and then I thought, this is one of those things where a little song helps you remember them, and it popped up.
What channel is this?
Let me hang on. Let
I
me
need to
tell
go
you.
check it out.
You need to check it out. Hang on. Let me tell you, because he's fun. I thought he was super duper fun. This dude. And it'll go just 1 second. It'll pull up here. There you go. So he is the Atmosphere Song. Let's go. Can we go to? It's on the Science Mom. Science Mom shared the video, but I don't think that's Science Mom singing, obviously.
I don't know.
Oh, wait, it could be her husband, because there's this dude.
Oh, yeah.
There's the geosphere. Oh, look. Oh, this is all earth science, a whole science. See, I didn't get a chance to look at this yet. I just like the atmosphere song. It's says Science Mom. So here's your earth science with Science Mom. Oh, there's a lot of them here. I don't know. Look at this. She's got genetics. Oh, see, I hadn't even been here yet. So math dad. Oh, he's math dad. And she's Science Mom. That could be this house. So, except I'd be the one singing, not Jason. So anyway, I thought he was funny. I was like, I remember this forever now. This guy's cool.
Science.
So yeah, Science Mom, you can find him there. I guess that's Math Dad doing the singing, and she's probably like, hey, Math Dad, I'm gonna make you do the singing. So he